the third and the last of the environmental management approaches, the precautionary management approach. In the last two lectures, we discussed the conventional and the adaptive approaches to environmental management. In this lecture, we will talk about the precautionary principle, which is applied when we have high scientific uncertainty and the cost of not acting or of getting things wrong is unacceptable to society. Before we get into the details of the precautionary management approach, let's review what we need to take away from these lectures. First and foremost, I would like you to have a basic understanding of the three different management approaches. So I want you to know under what circumstances the different approaches can be applied, what steps there are for their implementation, and what are strengths and weaknesses that the different approaches have. I also would like you to have a basic understanding of the environmental issues that I use to illustrate the different approaches. This doesn't mean that you need to know every detail about the chemistry of ground level ozone or the every date and all the aspects and specifics of the Great Barrier Rainforest Agreement, but I would like you to be able to describe the big picture concepts and ideas. For example, I want you to know that ozone is a secondary pollutant and emerges from NOx and VOC emissions that can be linked to motor vehicles. I also want you to know the key groups involved in the Great Barrier Rainforest Agreement and their priorities. So these examples should help you understand what the expectations of your knowledge for this topic are. Of course, you also want to be able to provide examples of other environmental challenges where these management approaches would be applicable. So given those sorts of expectations, let's talk about the third management approach, and that uses the precautionary principle. UNESCO, which is the United Nations Educational, Scientific, and Cultural Organization, defines the precautionary principle in the context of environmental management in the following way. When human activities may lead to morally unacceptable harm that is scientifically plausible but uncertain, action shall be taken to avoid or diminish that harm. There are three key parts to this description. The first and most important point is that human activity may lead to morally unacceptable harm. Later in the document, it further specifies that this harm can be related to humans or the environment, and it defines what morally unacceptable actually means. It includes potential loss of human life or health, a degree of irreversibility in the effects, unfair impacts on present or future generations, which links to this definition of sustainability, and unacceptable impacts on human rights, which relates to justice and equity. The second key point is that the potential harm only needs to be scientifically plausible, not certain. This acknowledges that the future is inherently uncertain, and there never is full certainty in science. And the third point that has to be taken to avoid the possible harm. So in other words, we should do everything possible to avoid the morally unacceptable outcome that scientific, and the key point here is scientific uncertainty, cannot be an excuse for not taking any action. So the precautionary principle is a very risk-averse approach to management. You're really trying to do everything possible to avoid the negative outcome. One of the aspects of the precautionary principle and the implications for precautionary management approach is that it reflects this risk-averse attitude, and it shifts the burden of proof. So under regular conditions, the default is that the environmental activists or people supporting the environment need to prove that the activities of, let's say, a factory, for example, have a negative impact. So to repeat that, what's very common is that if someone's concerned about the environment, they need to prove that this factory is having a negative effect on the environment. So if we flip that around, once a precautionary management approach is used, then the factory needs to provide proof that its activities do not affect the environment. This means that protecting the environment becomes a default position. But this risk-averse approach does not come for free because there's an opportunity cost associated with this approach. While not having the factory pursue a certain activity might be good for the environment, it also means that there are fewer jobs for the local community. And this loss of opportunity has to be acceptable to society. You can think of the precautionary management approach a bit like buying insurance. There is a possibility that your place where you live might get broken into, but it's not a sure thing. So to protect yourself, you buy insurance, but you only buy that insurance if the premium, the cost for that insurance, is not too high. With the precautionary management approach, you're protecting yourself against morally unacceptable harm that's possible, but not guaranteed. So the opportunity cost is equivalent to the cost of insurance, the insurance premium. Now, we have actually seen the precautionary approach in this course a bunch of times already. So when do you remember you've seen it before? The first time the precautionary approach came up in the course was when we discussed the Great Debate. The perspective of the techno-pessimist was basically that we were on a collision course with Mother Nature, and the scientific studies showed that there was a decent chance of an ecosystem and human population collapse. To the techno-pessimist, even just the possibility of this negative outcome was unacceptable, and the techno-pessimist advocated for immediate action. The techno-optimist thought that these predictions were too grim, and the opportunity costs for the proposed actions were too high. The second time the precautionary principle came up was when we explored the concept of planetary boundaries. Researchers don't really know how the Earth system will behave when pushed into new territories with respect to these 9 planetary systems, but researchers think that the likelihood of severe negative consequences is too high for us to ignore. As a consequence, the researchers recommend that we do everything possible to stay within the planetary boundaries that they defined as a precautionary level. In both these cases, the cost associated with taking a precautionary approach is the loss of economic opportunity for the current generation. The third time the precautionary approach came up in the course was the Rio Declaration, where the Rio Declaration explicitly mentioned this precautionary approach as a management approach. The declaration states that in order to protect the environment, the precautionary approach shall be widely applied by states according to their capabilities. Where there are threats of serious or irreversible damage, lack of full scientific certainty shall not be used as a reason for postponing cost-effective measures to prevent environmental degradation. The wording clearly states again that scientific uncertainty cannot be used as an excuse for non-action. Now let's look at a few examples where the precautionary approach to management is being used. One example is the Canadian Species at Risk Act, or known as SARA. The goal of the Species at Risk Act is to prevent wildlife species in Canada from becoming extinct and to promote the recovery of wildlife species that no longer exist in the wild in Canada, other species that are endangered, or species that are threatened as a result of human activity. Another aspect of the Species at Risk Act is to manage the species of concern to prevent them from becoming endangered or threatened. A species being, quote, endangered means that it has a very high likelihood of becoming extinct in the near future. Being, quote, threatened means that the species is vulnerable to becoming endangered in the near future. Once a species has been listed as endangered or threatened, the Species at Risk Act requires the government, the federal government, to develop a recovery strategy. And also they have to create an action plan that prohibits activities that would affect the species in negative ways and to protect what's known as critical habitat based on the best available scientific knowledge. The Species at Risk Act became Canadian law in 2002, and it is designed to meet one of Canada's key commitments under the International Convention on Biological Diversity, which was one of the achievements of the 1992 United Nations Earth Summit in Rio. Now, the Canadian Species at Risk Public Registry lists hundreds of wild plants and animal species that the government is trying to protect. One of the more iconic BC animals at risk of becoming extinct is the woodland caribou, which is shown on this photo on the slide. The federal government is currently working in collaboration with the provincial government of BC, Alberta, First Nation and Indigenous communities, and stakeholders to protect what's deemed as critical habitat to implement a recovery strategy. Now, why does the possible extinction of a species require a precautionary management approach? The answer, of course, is that it's the irreversibility of losing a species, and society has decided that this is unacceptable. Therefore, everything possible should be done to prevent this from happening. Another example of the application of the precautionary management approach is the international response to the depletion of the stratospheric ozone layer. As discussed in the lecture on the conventional management approach, there is good and bad ozone in the atmosphere. The good ozone is the ozone layer in the stratosphere, approximately 20 kilometers above the surface of the Earth. This stratospheric ozone layer protects us from the dangerous ultraviolet radiation coming from the sun. Having this protection was one of the necessary conditions for the development of life on land. In the mid-1980s, British scientists suddenly noticed a significant drop in the concentration of ozone in the ozone layer over Antarctica during spring. The sharp reduction in the concentration is clearly visible in the chart on the right. Initially, the researchers thought that the low concentrations were measurement error, but they confirmed the observations multiple times, and the pattern repeated itself every spring. The images at the bottom right show the extent of the ozone hole in different years, and you can see that in 1990, the ozone hole reached the size of the continental United States. Having lower concentrations of stratospheric ozone is really not a good thing, because there are serious consequences having increased ultraviolet radiation at the Earth's surface. First, there are serious health risks for humans, such as increased likelihood of skin cancer, cataracts, and other eye diseases, and a general weakening of the human immune system. There are also adverse effects on agriculture, forestry, terrestrial ecosystems in general, because the plants are negatively affected by the increased UV radiation. Similarly, plankton, which of course is the foundation of the food web and aquatic systems, plankton is also negatively affected by ultraviolet radiation. So having increased ultraviolet radiation is really something we need to avoid, because this increase in the radiation has dramatic consequences for humanity and in fact all living things on Earth. Now, why was the concentration of ozone decreasing over the Antarctic every spring? Turns out that the culprit for this observed decline was a new set of chemicals that was developed after World War II. Chlorofluorocarbons, which are known as CFCs, or known as Freon, are a really handy set of synthetic volatile compounds that are non-toxic and they don't really react with any other chemicals. And they're not very flammable. This means that CFCs are extremely stable, and as a consequence, they were widely used in firefighting materials, in spray cans as propellants, and in refrigerators and air conditioners as cooling fluid. The stability of CFCs also means that once the chlorofluorocarbons escape into the atmosphere, they stay there for a very long time. Now, by itself, this was not necessarily a problem, with the exception that CFCs are powerful greenhouse gases as well. But the real problem was that once the CFCs reach the stratosphere, they are exposed to increased UV radiation, and the chlorine atoms are split off from the rest of the molecule, and this starts a chain reaction that can destroy thousands and thousands of ozone molecules in the ozone layer. So it was a combination of the decay of the chlorofluorocarbons in the stratosphere and special weather conditions over Antarctica that caused the ozone hole to emerge every spring. What you see on this slide is a false color view of the total ozone over the Antarctic pole. The purple and blue are where there is the least amount of ozone, and the yellows and reds are where there's more ozone. The situation that is shown here is from the spring of 2006, when the biggest ozone hole was recorded. So we started looking at concentrations of stratospheric ozone. With the concentration of stratospheric ozone decreasing rapidly and the potential for serious consequences for human health and the Earth's ecosystems, the global community had come together to do something about it. And in 1987, the international community ratified the Montreal Protocol that mandated the stepwise phasing out of substances responsible for the depletion of stratospheric ozone layer. So, by 1996, 9 years after the protocol was ratified, CFC production in industrialized country had been brought down to zero. The rules for developing countries were slightly different because they did not have the same means for replacing these chemicals as quickly. The Montreal Protocol is a landmark treaty because it was the first time that an environmental treaty was universally ratified by all countries in the world. So the world really came together to combat this environmental challenge in a united and decisive way. So the question, of course, is, did it work? What you see on this chart is the maximum size of the ozone hole and the minimum concentration every year since 1979. So that you can see that the ozone hole continued to grow and the concentration continued to drop after the Montreal Protocol was enacted. But eventually, the management actions were able to stop the downward trend. We had the lowest concentrations in 1994 and the biggest ozone hole in 2006. And since that time, the measurements indicate that the health of the ozone layer is increasing again. What you see on this slide is the difference between a world with and a world without the Montreal Protocol. The red lines and the maps in the bottom row show what the situation would have been without the Montreal Protocol. The blue lines and the maps in the top row show the effect of the Montreal Protocol in 2014 and projected to 2060. Projections generally suggest that by roughly 2060, the stratospheric ozone layer will be back to where it was in the early 1980s. So on one side, the ozone hole is a powerful example of the possibility that human activities can have very large and unexpected environmental impacts. On the other side, the Montreal Protocol symbolizes that if necessary, the world can unite and work together to protect the Earth's ecosystem, and that we can all benefit from this collaborative work. Let's wrap this up with a brief overview of the three different management approaches. We used the complexity of the problem, or the associated scientific uncertainty and the severity of the consequences, as guides for our discussion. If the problem is relatively simple, with a clear pathway between human activities and the environmental impacts, the conventional management approach is appropriate and effective. This involves setting a target based on established science, coming up with focused interventions, and monitoring the progress towards the target. When we are dealing with complex problems that have many moving parts and many stakeholders and interested parties, and when we have only a limited understanding of how management actions might affect the system as a whole, there are two options. In the case where experimental learning is acceptable, we can use adaptive management. The adaptive management approach tries to achieve the best possible outcome given the current understanding of the system while conducting targeted experiments at the same time. This helps improve the understanding of the system that we're looking at, in this case the environmental system, and improves the effectiveness of management actions over time. And this leads to better decisions in the long term, this idea of learning by doing. If the consequences of environmental degradation are too severe or morally unacceptable, then the precautionary principle should be applied. In this case, everything possible should be done to avoid the consequences, and the key here is that scientific uncertainty cannot be used as an excuse for inaction. However, using the precautionary principle does mean that there are opportunity costs associated with the approach, because society has to be willing to accept these costs. I hope the last three lectures have provided you with a meaningful overview of the different options for managing environmental change.